In this screencast, we discuss the derivative of x to the x. So the derivative of the function x to the x. So the derivative of this function is quite different from the one that we saw before. For example, the base is constant, the exponent is a variable. We have a formula for that, and also we found if the exponent is constant, the base is a variable, we know how to do. That means, for example, if the question is find the derivative of 2 to the x, we know that this is 2 to the x times natural logarithm of 2. And similarly, if the base is a variable and the exponent is a constant, so this is twice of x raised to 1. So, but the question now we are going to deal is what happens if the base is a variable and the exponent is a variable. So in this case, we cannot use either of these techniques. So therefore, there will be another way to find the derivative of x to the x. So one way to find this is first we write x to the x in the form of e to something, like the way we did before. So therefore, x to the x is the same as e raised to ln of x to the x, which is the same as e raised to x times ln x. So this helps us to find the derivative in more easy way. So therefore, the derivative of x to the x is the same as, by chain rule, the derivative of the outside, which is e raised to x ln x, times the derivative of x times ln x, which can be obtained using the product rule. So therefore, this is e raised to x times ln x times the derivative of x times ln x plus x times the derivative of ln x. So this can be simplified to e to the x ln x is the same as x to the x, and the derivative of x is 1, so you get ln x plus x times 1 over x, which simplifies to x to the x times ln x plus 1. So therefore, this is the derivative of x to the x. It's quite different from the two examples that I stated above. So I think this answers some of the students' questions that they have difficulty to find x to the x. So I think this will be one simple way to find it. Okay, thank you for listening.